Okay, so for this activity, what I'm going to model for you is how you can use a variety of little materials to show rotation around a shape or about a shape with a center of rotation that is outside of the shape itself. So what I have here is I've got a pin, I've got a cutout of the shape that I'm going to work with, I've got a little piece of wood. Now you can use a little piece of cardboard too, just something to put behind your paper or underneath so that you can actually stab your pin into it to hold it in place. And I'm going to use the string to help guide the movement of my shape. So what I would do is I'm going to take the piece of wood, stick it underneath the paper. Now by doing that, it gives me a backing that I can push my pin into. So I'm just going to tuck that underneath there. So it's right here, the backing, so I can shove my pin in. It's going to stay in without me having to hold it. Now the next thing I would need to do is I might need a little bit of tape to attach the string onto my arrow. So I'm going to put it onto one of the edges or one of the corners, and I'll have to wrap the string around the pin, just around the point, so that once I take my pin and stick it in to the little piece of wood, now I can pull on the string tight, and it should allow me to use it as a guide for my rotation about that point of origin. So here is the dressed up example, if you want to call it, of my shape, my point or center of rotation that's outside of my shape. So notice it's not a part of my arrow. And what I've done here is I've taken the string, tied a small knot, pushed the pin through the little piece of cardboard underneath the paper, and then stuck the string on the pin. So what this allows me to do is it allows me to rotate my triangle attached to the string, because I've taped the string to this side of the triangle, or this side of my arrow. It allows me to rotate my arrow clockwise or counterclockwise. So let me mark it on my paper so I remember. It's really important to do this in an assignment too. So clockwise would be going this direction, and counterclockwise would be going in the opposite direction, like that. And that would be about this point. So if I wanted to go clockwise, I would be going this way. If I wanted to go counterclockwise, I would be going this direction. Now the neat thing is, if you go 90 degrees clockwise, it's the same as going a 3/4 turn in counterclockwise direction, or 270 degrees, because altogether, if you go all the way around the center of rotation, you create a circle, and the circle is 360 degrees. So let's try the first part here. What if you had to take this arrow and rotate it 90 degrees clockwise about the blue pin origin, which is not part of the shape? So clockwise rotation, that means you're going to need something as a marker. Now what we could do, that's why we put the string here. If you mark the string, so if we mark the string using our pen from the center of the origin, or the center of rotation, to the bottom corner of the arrow, then we know that a 90-degree angle would go from here to approximately here. That's about 90 degrees. So now what you have to do is you've got to take your shape and you need to rotate it. Now you'll notice that the string holds the arrow into position. And the string has to go onto that other line. And then that will give us a 90-degree rotation from our object to our image. And our image can be drawn here. Now we can just simply trace it, just like this. Now I'm going to put this back over to the object. Now I could use a ruler to fill in. Now the neat thing about this is, when you do your rotation about the point of origin, you'll notice it's not always the case, but in this case this corner doesn't seem to move either. Now I think it might just be lucky because we're doing a 90-degree angle and because of the shape that we've chosen. However, one thing you do need to make sure of is that your string that you attach to your shape the end point of your string, the distance between this arm and this arm, must give you your 90 degree clockwise rotation. So you can use your string to help you mark off the angle measurement, and you can use your protractor to actually measure between the arms. This arm of the original string and this is the image string. Now, if you wanted to take the same shape and do a counterclockwise rotation, let's say a 90 degrees to see what that might, or 180 degrees, see what that might look like. Okay, so 180 degree counterclockwise, we know counterclockwise is in this direction, because that's against the direction of hands on an analog clock, so that's 180 degrees counterclockwise. That means the string is going to be over here. Right? Is the arrow going to be pointing up or down? Well, let's find out. So we have to rotate it nice and slow. As you can tell, this is a 90 degree counterclockwise rotation, and we have to go 90 more. The string stays. Now the string has to be able to spin around on that pin. If the string gets stuck, it's not going to work. So you have to make sure it can turn, so you have to tie a little knot. So there we go. So that means this is 180 degree counterclockwise rotation, and that is from the original. Okay, now here, watch this. If you were to draw your 90 degree counterclockwise rotation, which would be from the original, which would go here, you'll see a nice arrow pattern where we're starting to draw a neat little picture of arrows following a pattern, and they all seem to be turning left. And that's just a neat little way of taking your artwork, or taking your math and actually creating artwork, because then we could do 45s in between the 90s and add another creative edge. And we're going to get into that soon when we talk more about different ways of changing transformations. So I hope this helps, and don't forget to double check your work. If you go from your original to your image, if it was a 180 degree counterclockwise rotation, how would you double check that? You would use a complementary rotation, which would be in the opposite direction. So in this case, because it's 180 counterclockwise, you would want to go 180 clockwise just to make sure it ends up in the same spot, and it does. So if you were to do a 90 degree from the origin to here, 90 degree clockwise rotation, the way to double check that would be to start the origin again and go complementary. So if it's 90 degrees clockwise, the complementary rotation to get into the same location would be 270 degrees counterclockwise. And this is for double checking to make sure it's accurate. So that means I'd have to go 90, 180, 270. And it does, I arrive in the exact same location. That means that this is a 90 degree clockwise rotation. So I hope that helps. Don't forget your think alouds, and please try and use the manipulatives to help you with your rotations.